Okay, let us see how do we rationalize the denominator, okay, where you have certain square roots therein. Let's say you have a square root 5 here, you have a square root 6 here, and you have a square root 7 over here. Okay, now basically if you were to notice, we know that a into a is equal to a square, right? Similarly, we know that a plus b into a minus b is equal to a square minus b square, right? So we will use these two identities in order to solve these equations. Okay, now what do you mean by that? Now please notice, just listen very carefully. Okay, if you have any square root number, okay, the only way you can remove the square root from these numbers is by squaring them. Okay, so if you do the square of root 5, you will get root 5 into root 5, which is 5. When we say rationalize the denominator for the following, what we mean is removing the square root from the denominator. Okay, and these can be removed only when you square this particular number. Okay, now we know that, let's say you have this fraction 6 upon under root 5. We know that if we multiply both the numerator and the denominator by the same number, the value of the fraction does not change. Okay, so let's say we multiply this by root 5 upon root 5. Why do we do this? Any guesses? The reason why we do this is, as I told you, if we square up a particular number, then the square root is removed. So by multiplying this under root 5 or square root 5 by another square root 5, I will be squaring off, actually not squaring off, I will be squaring this particular number, right? Now we know that 6 upon root 5 in this can be written as 6 into root 5 upon square root 5 into square root 5, right? 6 into root 5 can be written as 6 under root 5. Now this is of the nature root 5 into root 5 can be written as root a into root b, and we know that when we multiply these two square roots, what's the identity we use? We use root ab. So we can also write this as root 5 into 5, right? Or 6 upon root 5 upon 5 square to the power 1 by 2, which is nothing but these two will cancel it out itself, and you will get 5 over here. 6 root 5 upon 5. So what we have done is that we have removed this root 5 from the bottom and took it to the top. Similarly, if you notice in this one, 4 plus root 6 is of the nature a plus b, right? Now if you notice this, in a plus b into a minus b is equal to a square minus b square. Now in our case, this b is basically what is a square root number, right? To convert this, we have to multiply it by another number such that we are able to do the b square. So we already have a plus b. So what do? We need to multiply this by a minus b. But what is my a? A is basically 4. B is root 6. So 4 minus root 6, right? But if I multiply the denominator by a particular number, I need to multiply the numerator also by the same number. So I multiply 3 into 4 minus root 6, right? Now a plus b into a minus b is what? It's a square minus b square. So a is 4. So we'll write 4 square, which is 16, minus root 6 into root 6 is root 6 square or 6. 3 into 4 is what? 12, minus 3 into root 6 is 3 root 6. or we can just write this as 12 minus 3 root 6 divided by 10, and this becomes your answer. Why? Because we can't solve root 6 anymore, right? Now just like this, let me just clear this off. In this particular equation we have a minus b, right? So in order to solve this equation, I need to multiply it by what? A minus b is already there, so I need to multiply it by a plus b. So 4 plus square root of 6, right, into 4 plus square root of 6. So this again becomes a minus b into a plus b, right? This order doesn't matter whether you multiply this with this first or this with this first. The answer always remains the same, a square minus b square. So which we solved here to got 10. In the numerator you will have 3 into 4 plus root 6. 3 into 4 gives you 12 plus 3 under root 6 divided by 10. Okay, and we can't solve this also any further, so this becomes my answer. So just to recapitulate, the most important thing for you to see is how can you square the square root which is given to you. If it is alone, obviously you just multiply it by itself. If it is in the form of a plus b, where the only square root identity is b, you just multiply it by a minus b, and applying this identity, solve the numerator and the denominator. The denominator will get rationalized, and similarly over here also, right?